So in this video, we're going to look at some harder simple trinomial practice questions. So let's say we have m squared plus 10m plus 16. Well, we're going to follow our same rules from last video. We need to find two numbers that multiply to 16 that also add to 10. So let's think about this. Well, 16, we have 8 times 2. And if we add those together, right, 8 plus 2 is equal to 10. So starting off here, we're going to get this is equal to bracket m plus 8, bracket m plus 2. Okay, let's go on to our next one here. For this next one, we have 2n squared minus 16n plus 24. Okay, so this right here is not a simple trinomial because that leading coefficient, our a term, is not 1. But if we notice, all of our terms, a, or all of our coefficients, a, b, and c, can be factored by the number 2, or can be divided by 2. Meaning, if we divide each of these by 2, and we factor that out, we will get 2 bracket n squared minus 8n plus 12. Now, this right here is a simple trinomial. So let's solve this one. So we need to find two numbers that multiply to 12 and add to 8. So let's think of two numbers that multiply to 12. Well, we have 6 and 2. And if we multiply those, it's equal to 12. But if we try to add those, we're going to get positive 8. We need to get negative 8. So instead, let's try flipping our signs around. So if we do negative 6 times negative 2, well, two negatives multiplied make a positive, so we'll still get positive 12. And negative 6 plus negative 2 will equal to negative 8, meaning our answer for this one is we got to keep that 2 that we factored out. So 2 bracket n minus 6 bracket n minus 2. Okay, now let's go on to a little bit of a harder one here. Let's say we have 3r, 3r cubed minus 39r squared plus 120r. Okay, so looking at this here, this is nowhere near a simple trinomial. First off, we don't have squared and then r to the 1 and then just a coefficient by itself or a constant. We have r's in all of our terms. And also our leading coefficient is not equal to 1. So let's see if we can do some factoring, some common factoring here to get this looking more like a simple trinomial. So let's start with our numbers. Well, what are each of these numbers divisible by? They're all divided. We can divide all of them by 3. Right? If we divide all of these by 3, we will get 3 bracket r cubed minus 13r plus 40r. Sorry, and this is r squared there. Now, each of these still have an r in them, right? At least one r, meaning we can factor out an r from all of these as well. So now we're going to look like 3r bracket r squared minus 13r plus 40. Now, this right here inside the bracket looks a lot more like a simple trinomial. So now we got to find our two numbers that multiply to 40 and add to 13. So let's think of some things that multiply to 40. Well, we have 4 and 10, but if I try adding those, I'm going to get 14. So that's not it. Okay, let's think of some other ones here. We have 8 and 5. Right, if I multiply those, I'll get 40. If I add them, I'll get positive 13. Well, like our last question, we're trying to get negative 13. So let's just try flipping the signs of the 8 and the 5 there. So instead, we're going to do -8 and -5. And if I add these together, I will get -13. So these are our answers. So our final answer will look like, we got to keep that 3r. So this will be equal to 3r bracket x minus 8 bracket x minus 5. Oh, sorry, not x. R minus 8 and r minus 5. So r minus 8 and r minus 5. And those are some harder simple trinomial practice problems.